In this video, I'm going to talk a little bit about calculating components of vectors when you know the magnitude and direction of a vector. And in this, I'm going to be working in 2 dimensions. So that's the example that we're going to look at. And so a vector can be given by a magnitude and direction, this length here and this angle that the vector makes with the x-axis. The components of the vector are how much that vector points along the x-axis, that's the x component of the vector, and how much that vector points along the y-axis, that's the y component of the vector. And calculating those components will involve using sines and cosines. We're going to talk a little bit about right triangle trigonometry. In a math class, if you have learned about polar coordinates and you've learned about going from polar coordinates to Cartesian or XY coordinates, this is the same type of thing. It's the same process that you can do. So first, let's review a little bit with right triangles. For a right triangle, you have a triangle, and one of the angles in the triangle is a right angle. The side that's across from that right angle is the hypotenuse. That's the longest side in the right triangle. And then we have 2 other sides, the opposite and the adjacent side. So if we're talking about this angle theta in this left-hand corner, the hypotenuse and one of the other sides come together to form that angle. The side that meets the hypotenuse at that corner to form the angle theta is the adjacent side. And then the side that's across from that angle theta is the opposite side. And so the trig functions sine, cosine, and tangent are defined in terms of ratios of the sides of that right triangle. The sine of that angle theta is the ratio of the opposite side to the hypotenuse. If this angle is 30 degrees, the ratio of the opposite side to the hypotenuse is always going to be 1 to 2. The hypotenuse is always going to be twice as big as the opposite side. And so you might not know what the sides are, but you know what the ratio is if you know that that angle is 30 degrees. And so if you know one of them, if you know that the hypotenuse is 20 meters, you know that the opposite side was 10 meters. The cosine of that angle, theta, is the ratio of the adjacent side to the hypotenuse. And the tangent of that angle theta is the ratio of the opposite side to the adjacent side. You often learn SOHCA, TOA is the way of remembering. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. But you do need to know these definitions of the trig functions. Sine of an angle, the cosine of an angle, the tangent of an angle are just a number. It's that ratio of those sides. Notice the adjacent side is not always the horizontal side. If we're given this angle, theta, then the hypotenuse and the adjacent side meet at the corner that forms that angle. And so here, this vertical side would be the adjacent side, and then this horizontal side would be the opposite side. It's the one that's across from theta. And so you have to be careful when you're trying to find components of vectors. Make sure that you know whether that angle is the angle with the horizontal or the angle with the vertical. Make sure that you can identify the opposite side and the adjacent side so that you don't get your 2 components backwards. When we're dealing with components in physics, these components can be negative. If the x component of the vector points to the left, then the x component of that vector is negative. If the y component of the vector points down, then the y component is negative. So we're using right along the x-axis is positive, left along the x-axis is negative. Up along the y-axis is positive, down along the y-axis is negative. And figuring out whether these components are positive or negative, if you were to try and describe this vector A, this blue vector A that I'm looking at here, if I was to try and describe that in words, I would say that that arrow is pointing up and to the left. And so up is a positive y component, to the left is a negative x component. This vector down here is pointing down to the left. So down is the negative y direction, to the left is the negative x direction. So in here it's pointing down to the right. Right is the positive x direction, down is the negative y direction. And so in physics, we do need to take that into account, especially in the next part when we're going to be adding vectors together. We need to make sure that if a component points to the left or if it points down, that we include that that component is negative. So let's look at a couple of examples of calculating components of vectors. In this problem, we have Superman flying from the top of a building, and he flies 100 meters at an angle of 30 degrees down from the x-axis, or 30 degrees below the x-axis. And we're going to try and find what the x and y components of his displacement are. We want to figure out how far he moved horizontally and then how far he moved down vertically. So we're going to be trying to calculate this x component and this y component. And we can see this angle here, it's 30 degrees below the horizontal. So that tells us that he was flying down below the horizontal instead of flying up above the horizontal. Using sine and cosine, that's going to give us how big these components are. That will give us the size or the magnitude of the x and y components. When I write this out, I'm actually going to put absolute value symbols. It gives me the absolute value. It gives me how big that component is. And then we're going to go through and we have to include whether those components are positive or negative in our final answer. So I set this up. The sine of this angle, 30 degrees, is the ratio of the opposite side, which is this y component, divided by the hypotenuse, which is 100 meters. And you type in on the calculator sine of 30 degrees, and you get that the sine of 30 degrees is 0.5. So 0.5 equals the size of the y component divided by 100, or solving for that size of the y component, multiplying both sides by 100, I get that that size of the y component is 50 meters. So he flew 50 meters in the y direction. We'll include the sine in a second. The cosine of 30 degrees is the ratio of the adjacent side, which is this x component, divided by the hypotenuse. The cosine of 30 degrees is 0.866. So 0.866 equals that x component over 100 meters. And so then multiplying both sides by 100, I get that the size of that x component is 86.6 meters. But I said that the components could be negative. So looking at this, the x component is to the right. So that component is going to be positive. But this y component points down. And so my y component is going to actually be negative 50 meters. So he flew 86.6 meters to the right, and then he flew 50 meters down, or he flew 50 meters in the negative y direction. So the x component was positive 86.6 meters, and the y component was negative 50 meters. Looking at one more example, a person walks a displacement of 5 meters at an angle of 37 degrees above the x-axis. So this hypotenuse was 5 meters, and the angle was 37 degrees above the x-axis. And so we're going to calculate the x component of the displacement and the y component of the displacement. So to calculate this x component, here x is the adjacent side. The x component and the hypotenuse form this 37-degree angle. And so the trig function that relates the adjacent side and the hypotenuse is cosine. So the cosine of 37 degrees equals the size of the x component divided by 5 meters. I plug in on the calculator, cosine of 37 degrees is 0.7986. So 0.7986 equals x over 5 meters. Or we get that the size of the x component is 3.993 meters. And because this x component is pointing to the right, that x component is positive 3.993 meters. For the y component, that's the opposite side. And so I'm going to use sine. So the sine of 37 degrees is the ratio of the opposite side, y, over the hypotenuse, 5 meters. The sine of 37 degrees is 0.6018. So 0.6018 equals y over 5. And so when I multiply that out, I get that the y component is 3.009 meters. That y component is up, so it's positive 3.009 meters. You can see this was approximately a 3, 4, 5 right triangle. This y component was a little bit more than 3. This x component was a little bit less than 4. 37 degrees is approximately the angle in a 3, 4, 5 right triangle. It's really a little bit less, 36.9 degrees. In a couple of separate videos, I'm going to go through finding components of vectors, but then adding vectors together using the component method. So this is the first step in those types of problems. So you need to be able to calculate components of vectors, but then we'll be looking at using the component method to calculate the sum of two vectors.